Welcome back to the channel of Chem Pacific. In this video, I'm going to discuss with you all about the solution of some important CSIR-NET PYQs with best notes. Through this video, I want to make you all realize the fact that how good notes are actually important for better understanding. And also in future, if any kind of questions come regarding this concept, you can easily become ready to answer them on your own. Now, before we get started, if you want to explore more, consider subscribing Chem Pacific, and also if you like our video, to press the like button. Now, let's get started. Now, very first question is CSIR-NET December 2018. Now, this is the reaction. Okay, and they're asking the product of the reaction given below, and these are the reactants. So what is going to be the product? Now, in order to solve this question, let us first study this notes. This is the oxidative addition reactions. This is the oxidative addition reactions in epoxides. So basically, epoxides react with electron-rich metals like rhodium and iridium complexes. You must be knowing कोई भी oxidative addition के लिए, as because वहाँ पे oxidative addition हो रहा है, the electrons are given out by the metals. So the metals, because oxidation of the metal is taking place, so the metal should be electron rich. So that is why epoxide, when it reacts with the electron rich metals like rhodium or iridium, it results in the CO activation. This is very important, and through the primary product, it rearranges to form the hydrido beta oxoalkyl complex. Now this is very important. ठीक है, तो ये जो reaction है, if you see, it is reacting with the epoxide and resulting the formation of this due to the CO activation of this cyclic one, and then with this you will find this will get into this, and this will result in this, and with this it will result in the formation of hydrido beta oxo alkyl complex. So this actually results in the CO activation. This is very important. ठीक है? So with this CO activation, matlab this group is getting activated and resulting in the insertion of the metal. So this CO group is bond is getting activated and resulting in insertion of the metal, and later on rearrangement is resulting in the formation of hydrido beta oxoalkyl complex. So the answer over here is this. The answer number 1, which is the beta oxo alkyl complex, hydrido. Okay, so the answer is this. So this is nothing but, this reaction is nothing but the oxidation of the epoxide, oxidative addition of the epoxides. Now let us move on to the next question. This is CSIR-NET June 2018. So they are asking you, this is very important. So let me solve this, and to solve this question, let us study these notes first of all. Now basically, this is the addition of the CH bond. This is the addition of the CH bond in the orthometallation step. ठीक है, यहाँ पे if this is an oxidative addition, what are the main important characteristics? Point number 1, oxidative addition में क्या होता है? Oxidation of the metal takes place usually by 2 units. यहाँ पे oxidation is taking place of the iridium +1 to +3. ठीक है? And then also usually the coordination number increases. So यहाँ पे the coordination from the square planar to octahedral. Okay, so these are the two most important. यहाँ पे oxidation भी होता है, and the coordination number also increases by 2 unit, mostly from the square planar complexes to the octahedral complexes. So यहाँ पे जो आपका cyclometallation हो रहा है, you can also see that this orthohydrogen, this is the orthohydrogen. So this is the orthohydrogen, that is the hydrogen from the ortho carbon, which is actually in the ortho position. This is getting added to the iridium. Okay, so this is very important, and रिजल्टिंग इन ऑर्थोमेटलेशन एंड ऑल्सो यहाँ पे क्या हो रहा है, ऑक्सीडेशन स्टेट इज गेटिंग इंक्रीज फ्रॉम +1 to +3। तो यहाँ पे ऑक्सीडेटिव एडिशन हो रहा है ऑफ द इरिडियम, ठीक है। सो दिस इज वेरी इंपॉर्टेंट। तो आई हैव ऑलरेडी गिवन इन द फर्स्ट एग्जांपल, यहाँ पे क्या आ रहा है, ऑक्सीडेटिव एडिशन हो रहा है, जहाँ पे विच एन ऑर्थो कार्बन एंड द हाइड्रोजन जो है विच वाज एक्चुअली ओरिजिनली कोऑर्डिनेटेड टू द ऑर्थो कार्बन, वो क्या हो रहा है, दैट इज गेटिंग एडेड टू द इरिडियम, ठीक है। सो इन दिस रिएक्शन द मोस्ट कॉमन इज द ऑर्थोमेटलेशन एंड ऑल्सो यहाँ पे ऑक्सीडेटिव एडिशन हो रहा है। तो द टू थिंग्स दैट एक्चुअली टेकिंग प्लेस इज पॉइंट नंबर 1 इज द ऑर्थोमेटलेशन and also it resulting in the oxidative addition. Oxidative addition because the oxidation state of iridium is changing from +1 to +3, it is getting oxidized, and the square planar complex जो है it is getting converted to octahedral complex as well as यहाँ पे जो orthometallation हो रहा है, the name is derived from the fact that the ortho carbon hydrogen जो है ortho position में जो hydrogen है that is getting added to the metal iridium. सो यहाँ पे हमने ऑर्थोमेटलेशन स्टडी किया है, बट दिस इज एन एग्जांपल ऑफ साइक्लोमेटलेशन, बट नॉट नेसेसरीली दैट्स ऑल द साइक्लोमेटलेशन में आपका ऑक्सीडेटिव एडिशन होगा। तो जो भी हमारा प्रॉब्लम है उसका तो नोट्स में आपको दे ही रही हूँ, उसके साथ मैं कुछ एडिशनल इंफॉर्मेशन दे रही हूँ सो दैट इन फ्यूचर इस टॉपिक के ऊपर कोई क्वेश्चन आए आप उसे इजीली सॉल्व कर पाओ। तो अनदर एग्जांपल में जो दे रही हूँ आपको साइक्लोमेटलेशन, जहाँ पे साइक्लोमेटलेशन तो हो रहा है बट वहां पे वेरी इंपॉर्टेंट, इवन दो वहां पे साइक्लोमेटलेशन हो रहा है बट वहां दिस इज नॉट एट ऑल एन एग्जांपल ऑफ oxidative addition. This is not an oxidative addition because the oxidation state of platinum is remaining the same. Okay, so always keep it in your mind that सारे के सारे ऑर्थोमेटलेशन not necessarily will undergo oxidative addition. Some might also take place, and in this case यहाँ पे ortho position में there is absence of hydrogen. It actually in the meta position hydrogen is getting added to the it's coming out, resulting in the formation of CH4. This is also an example of cyclometallation, but this is not an example of oxidative addition. ठीक है, the mechanism is completely different. यहाँ पे कोई oxidative addition नहीं हो रहा है. This CH3 and this they are actually coming out due to heat, due to resulting in the formation of CH4, and यहाँ पे कोई भी change in the oxidation state नहीं हो रहा है. So as per the notes we have come to know that this option is correct, that the oxidation state is increasing from 1 to 3. यहाँ तक हमें समझ में आ गया. Now the next thing, next they are asking that what about option number C? This is a beta hydride elimination reaction. This is incorrect. Now 1 and 2 are both diamagnetic. This is very important question. Students यहाँ पे बहुत confused रहते हैं क्योंकि कभी भी आपको diamagnetism अगर study करना है, students ओनली इलेक्ट्रॉनिक कॉन्फ़िगरेशन ऑफ द मेटल देख रहे हैं, बट हम जो डायमैग्नेटिज्म स्टडी कर रहे हैं ये ओवरऑल कॉम्प्लेक्स. फॉर एग्जांपल आई एम टेकिंग द कॉम्प्लेक्स 1. Today in this video I'll teach you how to study the diamagnetism or the paramagnetism property of a complex. यहाँ पे keep it in your mind that हम क्या कर रहे हैं, हम ओवरऑल कॉम्प्लेक्स का मैग्नेटिक प्रॉपर्टी स्टडी कर रहे हैं, नॉट विद द मेटल. फॉर एग्जांपल इन दिस केस फॉर द कॉम्प्लेक्स नंबर 1 we are solving the complex number 1, right? So we know the electronic configuration of iridium is 5d7 6s2. Since in this case iridium is in +1 oxidation state, it will turn out to be 5d7 6s1, or you can also write it as 5d8. Now see, let's study about the nature of the ligand. वहाँ पे nature of the ligand ये जो PPHG है, they are sigma donor pi acceptor ligand, मतलब very strong free ligand. So they will result in the pairing of the electrons. ठीक है, they will result in the strong pairing of the electrons. Now let's see. So with iridium +1, if you draw this, This is 5D. Then you have the 6S and also the 6P. Since PPH3 is a very strong field ligand, and you know this is 2 electron donating ligand, that is why it will help in pairing up of the electrons. तो यहाँ पे कितने थे? 1, 2, 3, 4, 5, 6, 7, 8. Now PPH3 is a sigma donor and pi acceptor ligand. So what kind of ligand is this? Is a strong field ligand, which will help in the pairing of the electrons. So यहाँ पे जो unpaired electron है, this will result in pairing, and then PPH3 is 2 electron donor and Cl minus is also 2 electron donor. I hope you must be knowing this. ठीक है? So PPH3 being a 2 electronic donating ligand, you are having 3 PPH3 and 1 Cl minus. This will result in the formation of DsP2 hybridization, that is a square planar geometry. So it is visible to you that there is absence of any unpaired electrons. That is why this is a diamagnetic complex. Very important. स्टूडेंट्स यहाँ पे बहुत ज़्यादा कंफ्यूज रहते हैं. ऑलवेज रिमेंबर, डायमैग्नेटिज्म है या पैरामैग्नेटिज्म है, वो आपको ओवरऑल कॉम्प्लेक्स का ही स्टडी करके आपको आंसर करना है. ठीक है? सिमिलरली ऐसे ही आप ये अगर सॉल्व करोगे, यू विल फाइंड आउट. सो यहाँ पे जैसे आपका हो गया, यू विल फाइंड आउट दिस इज ऑल्सो सिमिलर वे में आप इसे सॉल्व करोगे. दिस इज ऑल्सो डायमैग्नेटिक. Similar way में solve this, you also find this to be diamagnetic. So both of them are diamagnetic in nature. And थोड़ा सा अगर मैं इसे और थोड़ा सा elaborate अगर करना चाहती हूँ, in order कि आप जानना चाहते हो how is PPH3 is a true electronic donating ligand. Now let me explain that to you. I believe you must be knowing that, but ठीक है, एक बार मैं उसे भी डिस्कस कर लेती हूँ. ठीक है? So electronic configuration of phosphorus in PPH3. This is the electronic configuration of phosphorus in PPH3 is 3s2, 3p3. Okay, 3s2, 3p3. So this is resulting in the formation of sigma bond with 3pH, and there is only availability of lone pair of electrons which is consisting of 2 electrons, and that is why PPH3 is a 2 electronic donating species. And due to the presence of, and since also this is having vacant d orbital along with the addition of lone pair of electrons for donation, so this is a sigma donor and pi acceptor ligand, which makes the ligand enough strong field ligand so that it can actually pair up the electrons. ठीक है? And similarly Cl minus is also 2 electronic donating ligand. So I hope this is a very important topic, because I know very well students को यहाँ पे confusion होता है. वो diamagnetism जब पढ़ाई करते हैं, they will only think about the metal, but that is not actual scenario. You have to study the magnetic property of the overall complex. So the answer is then, and both of them are actually diamagnetic. So therefore the answer is 2 A and C. This is not a migratory insertion. Okay, so so we have solved this question. I hope you understand this. Now let us move on to the next question. Now The next question is regarding the CSIR-NET December 2016, and they are asking this question, the treatment of FeCO5 with this. So the reaction is taking place between FeCO5 with 1,3-butadiene, resulting in the formation of B. That shows two signals in the H1 NMR spectrum. B on treatment with HCl yields C, which gives 4 signals. This is very, very important. So C is resulting in the formation of 4 signals, okay, in its H1 spectrum. They're asking for which one is the compound C. Very important question. So in order to solve this question, let us study some theories. This is the allylic ligand, and यहाँ पे I have given you this beautiful notes where पे the complex where the metal center is not protonated directly. This is an example where पे the metal centers are not protonated directly, and the protonation of this butadiene can result in the formation of the eta 3 allyl complex. Okay, now this must be known to you that FeCO5, first of all, FeCO5, you must be knowing that CO is a 2-electronic donating ligand. It must be reacting with cis-butadiene, 1,3-butadiene. Okay, so this must be in the cis form. Okay, cis 1,3-butadiene. This is resulting in the formation of B. यहाँ तक सबको पता है. ठीक है. Now since we know that one double bond is actually 2 electron donor, so this will actually result in the will get coordinated, and this will result in the elimination of 2 CO ligand. ठीक है. Now ये तो आप सबको पता है. This is very. Now when this actually reacts with HCl, it actually results in the protonation. It actually results in the protonation of the allylic complex, not with this. ठीक है. This is very important to note. तो जब हमें ये मिल गया है, when it is reacting with HCl, so it is resulting in the protonation of this group. It does not protonate the metal, and the Cl is getting bonded to this. This is very important, okay, and resulting the formation of the product. Okay, now therefore the answer is this. They have also mentioned, this is the C, they have also mentioned it is resulting in 4 signals. Obviously this is, you're getting one signal due to this proton. This is in the different environment, 2, 3, 4. So in this complex you can see there are protons which are present in 4 different environments, resulting in the formation of 4 signals. So these problems are very important, so resulting in the formation of 4 signals. I hope this is clear to all of you. Okay, now let us move on to the next question. This is CSIR-NET June 2017. They are asking that what happens when the reactant reacts with this group and resulting the formation of A along with NaCl. Photolysis is very important. Photolysis of the compound A results in the formation of compound B with the elimination of CO. Now what is the correct structure of the compound A and B? Now this is very important. यहाँ पे nucleophilic substitution हो रहा है. So let us study these notes first of all, and this is very important, students. यहाँ पे you should not remember this as this. You must understand यहाँ पे nucleophilic, this is acting as a nucleophile. यहाँ पे nucleophilic substitution ही हो रहा है. ठीक है, ठीक है, यहाँ पे nucleophilic substitution ही हो रहा है. So this is a nucleophile, this is resulting in the nucleophilic substitution, and this is in the eta 1 mode, and when it is undergoing photolysis, this is the H nu, the hapticity increases from eta 1 to eta 3. So always remember how the change in hapticity takes place. The change in hapticity takes place when it undergoes photolysis. In the with reaction with H nu. So lower hapticity actually changes to high hapticity. So if you want to increase the hapticity, it must undergo true photolysis, resulting in the increase of hapticity. So with this note, I hope you will understand that in this case, the answer is going to be this one. This one is the A. This one is the A, which actually result in the formation of the eta 1 mode. जब वो H nu it undergo photolysis, it result in the formation of the eta 3 mode, and A actually came due to nucleophilic substitution. Okay, so now let us move to the last question of this. So whatever the problems I'm solving you, I'm trying to give the notes from the authentic books. I have done a lot of research and development, and I'm trying to make notes, good notes from the good authentic books, so that you understand how much important for you to study and learn science and the theory to make yourself self-sufficient to answer any kind of questions. Now this is they're asking for the oxidation state of the molybdenum in this. Now, to answer this question, let us study this theory. This is the cycloheptatrine and tropylium ion complexes. Now, this is very important. In this complex, it is resulting in the hydride ion abstraction. Now, this is very important. What is the difference between an electrophile? What is the difference between an electrophile and hydride ion abstractor? So basically, if you want to make an electrophile to turn out into an hydride ion abstractor, it has to, if you want to turn out one electrophile into an hydride ion abstractor, it is very important, you must make the electrophile bulky, very important. So it will no longer act as an electrophile, it will act as a hydride ion abstractor. For example, I am taking PH3, this. So this is one hydride ion abstractor, because with this carbon is associated with 3 bulky pH ligand, so that it can act as a hydride ion abstractor. Why is it so? क्योंकि जब भी आप एक इलेक्ट्रोफाइल को अटैक कराते हो, you know that it undergoes through the transition state. अगर इलेक्ट्रोफाइल बहुत ही bulky हो जाता है, then the transition state turns out to be extremely unstable. So it acts as a very bad electrophile, but it can act as a very good hydride abstractor. This is very important. ठीक है? So that is why in this case our hydride abstractor ion abstractor जो है, so this is our hydride ion abstractor. So this is our hydride ion abstractor. Okay, so it is resulting in the formation of the cycloheptatrinyl or the tropylium complexes. So यहाँ पे it is coming out the H minus, ठीक है, resulting in the formation of PH3CH. So this is acting as the hydride ion abstractor. It is accepting the hydride, resulting in the formation of PH3CH. ठीक है, if it is taking out the H minus, obviously this will turn out to be plus sign. So that is why the name is tropylium. Lium means it is resulting in the, so this is tropylium. So the word lium means it is one cationic species. Now this tropylium ring is actually planar with equal CC distance. So like benzene as well as the cyclopentadiene ion, the tropylium cation is aromatic in nature and this is a 6 electronic species. ठीक है, अगर ये positive charge is due to the abstraction of the H minus, फिर क्या होगा? फिर molybdenum का oxidation state यहाँ पे क्या है? The oxidation state of molybdenum is 0, है ना? Because this plus sign is due to the abstraction of the H minus, which has been abstracted by the hydride ion abstractor, which is actually bulky in nature. ठीक है? So in this case, the oxidation state of molybdenum in eta 7 tropylium CO this is 0. Very important questions. So I hope you like your video. Thank you for watching our video. And if you like your video, do press the like button. Thank you for watching our video. Thank you.